Now we will have a brief look at the factors which play a role in specifying a tolerance for a certain dimension. So if you are a design engineer and if you are designing parts, and if you have to decide what would be the tolerance range for a certain dimension, for a certain feature, what would be the factors which we need to consider? We will have a brief look at that. So the first factor is the precision required for the application. There can be applications which require very high precision, require very close tolerances, that is the tolerance range is very small, like in micrometers, or there can be applications which require very open tolerances. So tolerance range can be in the range of 1 mm, 2 mm, especially in the case of castings. So depending on the application, these precision ranges can vary. For example, if we are designing machines which are required for measurements or inspection, then you would need to have very fine tolerances, which are maybe to the level of gauge tolerance. So depending on the application, this precision will change and the tolerance levels also will change. Second is functional importance. So in a mechanical design, there can be many different features, many different parts which have different functional importance. Some parts are more functional important compared to others, and hence those dimensions or those critical dimensions have to be toleranced in a very careful manner. So functional importance is a very important factor in specifying a tolerance. Especially when it comes to interfaces in mechanical design, the tolerances can be of very high functional importance, as we have already seen from the example of the hinge. Also, if we take the example of a shaft in a rotating machinery and a bearing which is being installed on it, so that fit would generally be an interference fit which would require the bearing to be fastened onto the shaft. In that case, the tolerancing system between the shaft and the bearing is of utmost importance. Next point is costs associated with manufacturing. Let's say if we are manufacturing a shaft with a turning operation. So if we are doing coarse turning, then we would have open tolerances, that is the tolerance range would be larger. But if we are doing additional operation of fine turning and then grinding, then the cost required for manufacturing that shaft will be higher. But the tolerance range which we can maintain will be much smaller. And so it means that the finer the tolerance you want, the higher the cost will go for the manufacturing. The same is the case with all the other processes as well. The next point is process capability. As we have already seen, all the manufacturing processes have their limitations. Some manufacturing processes are versatile, some are not. So as we have already seen, the casting process cannot make parts which are having very fine tolerances. Hence, that has to be kept in mind while designing for those processes. And finally, assembly considerations. To make sure that assembly takes place between two parts, the tolerances, the locational tolerances, the orientational tolerances, the size tolerances have to be accounted for before specifying the tolerance for the mating feature dimension. So for an example, in machining operation, open tolerances are the liberal tolerances which are generally low cost and require a rough cut, like rough turning, rough facing. Close tolerances or small tolerance bands which are finer require finishing operations like grinding, super finishing, lapping, which have very small tolerance bands.